29. Questions on the crime problems. Which ones do you want to review today?
Three on the apply.
3 apply. All right. Let's see. Share screen. Let's see. I got it over here. All right. Number 3. Okay, using the example shown in figure 23.3 as a starting point, suppose that potential victims take measure to protect their property and the loot decreases from 120 to 50. Illustrate the values associated with the new lottery, including the new value of the certainty equivalent. Okay, who would like to share their work on that one? And I can pull it up, or you can pull it up. Who was the I can? Was that Daniel? Okay.
Yeah. If you'll give me like 2 seconds to open it.
I actually have it open already, so I should be. I'll just go ahead and share it.
Okay.
I was prepared a little bit more today rather than having to open it all up. All right, what page is it on? Okay, it looks like it's on here. All right.
Oh yeah, I had to submit it differently this time for my phone, so it might look a little weird. Hopefully it looks legible.
There, this one?
Yes, perfect.
All right.
So I had to write with my left hand, so sorry for the bad handwriting. But loot decreased from 120 to 50, like the problem said. So that means that our total lottery goes from 50 to negative 25 with a 3/5 chance of loot and a 2/5 chance of getting caught. And G equals 3 and L equals 6. That's gain and loss. So the expected utility is going to be the 150, which is 3 times 50 from the graph.
And before, just to add on while you're talking here, just to kind of bring it, we were at 120.
Yes.
And then this would have kind of continued on, and this was 360, right? Whoops.
Yes.
All right. 360. Okay, gotcha. Yep.
Yes. So now we're at the new values of the 150, which is the 3 times 50. And then you multiply that times 3/5, and that gives you 90. And then with the loss, we're at the negative 25 still, which you multiply that by 6, which gives you 60. And if you do the math to add those together, or negative 60 rather, you add those together, you get 30 for the EU.
Okay.
And then the certainty equivalent would be just divide that number by the gain, or the G. So 30 divided by 3 is $10. That's where that comes from.
Right, which is just following this line here. So we have a continuous slope. The slope was the relative utility, transforming basically dollars into utility at 3 times. So that was the G factor that you mentioned, right? So it's, if you have $50, and I can probably circle what you did rather than rewriting it, but 3 times 50 is the 150 that you had. Okay, I think that looks pretty good. I didn't even look at the answers. Luke, did that help you out?
Yeah, it's just the answer in the book said 0, 0.
Yeah, it says 0 on the answer key.
And so I was just making sure that the math I got, someone else got too, pretty much. And so I got.
So what you did end up recalculating what Daniel got?
Yes.
Okay.
Sweet.
So good. Yes. Don't always totally rely on, 0, 0. Expected utility 0, certainty equivalent 0. Yeah, I don't think they did that right, because what you described looks like the right deal. So any further questions on number 3? All right. Any other questions you want to review?
Can we go over review number 13? I just have a quick question about it.
13. Okay, since your thing is up, why don't we'll just roll down to your 13. Is it on the next PDF though?
Yeah, it should be on one of those pages.
Let's see. That must be the next one. I don't think, let's see, can I get to the next page? I might be able to. Well, I think I need to zoom out and go to do it like this.
Yeah, it should be on there. Yeah.
Okay.
So I just wanted to know.
I guess let me go ahead before you start. Let me go ahead and just pull the question up so that we can.
Good idea. My bad.
So 13. Oh, we were missing 13 then. Is that right?
Oh, it's the review. You're on the.
Oh, on the review. Okay, okay. Got it. All right. Several factors play a role in diminishing returns to the length of prison sentences. Okay. And so this was kind of a look it up in the book type problem, correct?
Yeah.
Okay. Let me pull your thing back up. All right.
So my question is, the last one, number 4, it said was prison schooling, but I don't know if I understood that correctly because I thought it meant like, does that mean that the prison is like teaching them right from wrong, or does that mean that they're like learning from each other? Like how to, because whenever you described it in the presentation, I think you said something like they'll teach each other how to commit better crimes.
Yeah, exactly. And so that would be the longer they're in there, the more that they can learn how to become a better criminal. Because this is where hardening the criminal was the other thing. Yeah, that's right. So it is, if we give them a longer sentence, they're only going to potentially have more time to learn about other crimes as they sit in there. So that is the prison schooling one, yes.
Okay, all right. So I misunderstood that. Okay, that makes sense.
Okay, any other ones? Sounds like you guys got it pretty good then. If you don't have any other questions, I thought we'd be going over at least one other model. Nobody's got another one?
You want to go over number 7 on the apply?
7 apply, sure. Let's see. I guess since we have yours open, just go back.
Oops. I think it's on the.
Oh, it was on that other page. Okay.
The top one.
Was it this one?
The top.
Okay, gotcha. Oh yeah, okay. This is the one let's see.
Oh, it's sideways. Oh man.
Yeah, I don't know let me see if I can turn that sucker. I'm not sure I can.
Next time I'm definitely going to be submitting it like a PDF. Like
rotate.
At the bottom, can you? Bottom of the page.
Who else wants to share their work for this one? I'll pull it up while you guys think. Let's look at the problem first. All right, education and crime. Consider city with 20 workers and 2 occupations, robber and electrician. For each occupation, the payoff curve, the payoff as a function of the number of workers, has a slope of -2 utils per worker. In the initial equilibrium, there are 10 robbers, 10 electricians, and a payoff of 20. Suppose the government subsidizes community college programs and thus increases the productivity of electricians, shifting the payoff curve upward by 12. Illustrate the new equilibrium, including the values for number of electricians, number of robbers, and the equilibrium payoff. Okay, who wants to share? So, Daniel, give me a number between 3 and 12.
11.
11. Geez, such a big number here. All right. Let's see, where'd you go? There's Daniel. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Claudio, you are a lucky contestant. Let's go see what Claudio did. Let's see here. Boom. Claudio with a Q. Let's see, where are these problems? There they are. All right, so Claudio, you can unmute and tell me what you were, do you remember this problem or the direction you had?
Can you hear me?
Yep, now I can.
Okay.
What number was this? 7?
7.
Yeah. So, if I remember right, what I tried to do is
Is it this one?
calculating.
Yeah.
I don't remember the problem, but what I tried to do is calculate the new equilibrium.
Okay. Why?
Can you pull up the problem, Russ? I guess I can.
The actual question? The question?
Yeah, the question. I just don't remember the question. I don't have it.
It was this. I had it up earlier already. So education and crime. Consider a city with 20 workers. So there's 20 and there's 2 occupations only, robber and electrician. So, and if you just took a guess or kind of made up some work and you don't really know what you're doing, then just fess up.
Yeah, no, I just thought like so since there is just 2 jobs, I need to find the new equilibrium payoff, but I just kind of guessed and did like I did 20. I got 13 and 26. Yeah, I wasn't sure what I was doing, right?
Okay, fair enough. Who's next? Who wants to? Who thought they did an okay job with this? I'm not going to pick you apart too bad. Claudio, number between 2 and 5.
3.
1, 2, 3. Brady. Why don't you go ahead and unmute? What'd you do on this one?
I kind of just drew a couple pictures.
Okay, are they any good?
I'd give it a solid 6 out of 10.
Okay. What do you think is the key with the college thing and it's shifting up? What do you think the key is to answering the problem? Is this is your number 7 here?
Yeah.
Okay. Well, I'd like to see you have better labels for sure, especially for the
That's
final
fair.
exam. So tell me what's going on with the picture. I kind of like it. I mean, walk me through it. It looks like you're on kind of the right track. It needs a little more detail, but.
Can you hear me now?
There, now we can. Yep.
Okay.
Then you went away.
Okay.
If you want, you can use mine. Me and Brady worked on this together, so I've
Okay.
done the same thing.
All right. Brady, you want to give it one more try? Or is maybe you're having some internet problems. All right, let me try Luke, if you guys worked on it together. It looks like you're on the right track there. Let's see, next page, I'm
At
guessing.
the bottom of that one.
Oh, it was at the bottom of that one?
Yeah.
Ah, okay. All right, take it away, Luke.
So the one on the left, so like on the vertical axis is the payoffs for let me see the problem to be sure. For either being a criminal or an electrician. So the one on the right is for burglars. And the
All
one
right, so this was the robber one here, robbers. Oops.
sorry, I'm trying to look, I can't remember.
Okay, so there's our robbers. Here's our electricians. Okay.
I don't remember which one I did.
Yours is a little different than Brady's, slightly.
So basically what I was trying to show though, is that the electricians basically have an increase in utility for whatever reason, like the production gets easier or something, so they become happier.
Okay.
The more they are.
That's this new curve here, right?
That's the new curve. And basically,
Now,
I was trying to show.
Let's get, oh, I see. You have a 12 unit. You started them off at 20.
Yes. So each one, because it said that there were 10 robbers and 10 electricians with the payout
Yes.
total 20 utils. And so I was like, that's where the starting point is for both, basically 10 in each, both at 20.
Now, how come you have 10 here then if they're both starting at 20?
Oh, I meant to put a 20. I didn't mean to put a 20.
Okay, so we'll edit that to a 20. Okay, so that's our starting marker.
Yeah. So, but those are supposed to be 20s.
Okay.
And then basically I tried to show that this is where I kind of got confused because I understood where to start it.
Okay.
Basically because I knew that the electrician curve was going to shift up, but once I got to like.
And up by how much? How much does each?
It said by 12 utils, so from that point it would have been.
So then you should go up 12 and then over.
Yeah.
This should be lining up with your 32, right? 12 plus 20 equals 32.
Yeah.
Okay. And now what?
Then this is where I don't know.
Okay, so let's kind of reason through this. Everybody on the chat box, tell me what happens now where you've got, remember under these scenarios, we're assuming that we have a rational criminal and the payoffs each were enjoying 20 units of satisfaction in equilibrium, right? But then the higher education lifted the payoff to 32. The robbers are left with 20 and the good guys have 32. Good guys being the electricians. So what would happen to move back to equilibrium? One way to think about it is, why is this a disequilibrium? I'd like to see you guys put this in the chat box, and it's okay to be wrong. So you've got robbers and electricians. Okay, so Eddie, the payoff for the electricians rose. So robbers moved over. Good, okay. So 13 electricians making units. Okay, so Daniel's got it going down. And that's the trade-off. What's the rate of change? So as we lose a robber, what happens to the robber's utility? Chat box. I kind of want everybody to walk through this. So as we go from 10 robbers to 9 robbers, what happens? It goes up, right? Because there's less competition is one way to think about it. They have potential for more. So it's going up. And how much did it go up by, according to the assumptions of the problem? 2. So we have a 2 util gain, so that now we're at +2 at 9. And then of course this would be 22 over here. This is going to get muddier than I can probably do with my fat finger. But when that robber came over here, what happened to the 32 worth of value to the electricians? Did it go up or down? It goes down by 2. So that's where we're trying to find equilibrium. This is kind of similar to those utility problems we did before. At 11 electricians, now they're competing with each other, and it's going to go down to 30. And so where do they end up? Where is equilibrium restored? 26. 7 robbers, 13 electricians. So you can kind of keep doing it incrementally if you wanted. You could actually set up a little equation, is another way you could do this, to see where they end up. Okay, so any questions? If you want to unmute, any further questions on that one? Any other problems you want to review? This is your time to review. We could see any of these on the final, so you should know what you're doing if you weren't sure.
So you're looking for the equilibrium, you said? Sorry.
The equilibrium ended up being 7 robbers and 13 electricians. I assume that was in the problem, right? Yeah, 13, or I'm sorry, in the answer key, 13 robbers. So basically, we end up coming down to 7 robbers. Let me try changing colors here. Let's go with yellow. So we got 7 robbers and 13 electricians, both with a equilibrium utility of 26. And so that is a Nash equilibrium. Neither agent would like to change their profession, taking as given what the other one's doing. So we're back to a Nash equilibrium. Okay, anything further on that one? All right. We will call that good and start in on our final chapter, total excitement. So our last chapter is chapter 20, called The Role of Local Government. So we're going to take a peek at that here. Let me come back here, bring this in. Oops, I got the stupid, let's see, escape. Oops, I got to click this out of there. My slideshow, change to primary monitor, and try that again. Okay, local government. Okay, so we've talked about this before on the idea of federalism, where we have a limited federal government and we push things down to the local levels. So our founders of the great United States of America had this idea of let's keep the federal government real small, like just general rules, push power down to the states. And now the states can look different from each other. So the minimum wage in this state doesn't have to be the same as this state. The federal, and I hate to bring kind of a non-market mechanism right away, but the federal minimum wage is $7.25. That applies to all the states, but the states can have a higher minimum wage if they want, as we've seen here recently. And then finally, we get down to the county and the city level. And today we'll even talk about a metro level, which might be kind of a combination in the county and city level. So there's multiple cities within each county. And so as you move down the line, we have more customized rules at the city level that can help better serve maybe the unique circumstances that are going on in your city. Maybe it's Florida, where there's a coastal town where the ocean is an issue versus, somewhere in Ottawa, Kansas, or way up north where they have to deal with snow in Minnesota, where I'm originally from, versus Texas. So that is the type of thing. And then we're going to look at voting and how that works and potentially generates some inefficiencies. So just to give you a little overview of governments, this was back from 2002, which is similar today because cities don't change too much. There isn't like brand new cities too often. It's probably a little bit bigger, but at least gives you the idea of the breakdown in the United States for local governments. So county governments, 3,000. So we have 3,000 counties basically throughout the United States. And then municipalities and townships. Townships were defined by the legal system, and sometimes those can be the same as a municipality, but it's just technically different the way it was originally defined. So those two are kind of similar. And then schools and just special purpose things like unique water treatment type stuff, or unique little small governing things that might have a special purpose. So spending by local governments in 2012. So this is per capita, so per person. How much are we spending on education, police? And this is just $300, public assistance, highways, public transit, fire protection, and then miscellaneous other. This next slide I got has a little more details. And I think it's just kind of nice to see where my tax dollars are going. So most of the tax dollars at the local level are collected by property tax. So here in Ottawa, our property tax drives that. I pay about $3,000 per year, to give you an idea. Some of you have been to my house. So in Ottawa, Kansas, our property taxes are actually relatively high compared to some other municipalities. That was something I spoke to the Senate about, and other people have raised concerns about property taxes being too high in the state of Kansas in general. But I pay about $3,000. So this is kind of, roughly what I pay in for property taxes. And so most of that's going towards education, police, and all of these are ordered all the way down. So on average, that's what it looks like across all of the local governments. All right, 10-second pause for questions.
Is this like information available? Like, because you might pay $3,000 in property taxes, but I'm curious to like what I might pay for property taxes here.
Yes, so great question. And let me even take one step back and say one of the things that we hold near and dear to our heart in the United States is that there is supposed to be no taxation without representation type of stuff, and transparency. So all of that stuff is public record. Like you guys could go look at what my taxes are on the public records. So anybody in the whole city can get it. And then furthermore, when they send me my property tax statement, it doesn't have all these categories on it, but it does show the various things that your local property taxes are funding and the levels that were set. So that is one way that the politicians are, I guess, accountable for the taxpayers. The taxpayers do have that information. They're not just said, oh, you got to pay $3,000 and you wonder where it's going. So good question. And that doesn't always happen in other countries. So that's something that through the rule of law has been important in the United States as the system has developed. Any other comments or questions?
You said like 3,000 is like kind of high for where you're at. So like what does a normal property tax like equate to?
Well, so I'll give you guys a little brief idea of how this works. So I'll just use this thing here, I think. So here's the city of Ottawa, and the tax assessor, one of my fishing buddies actually works there now. So here's all the houses in Ottawa that are potential pieces of property that are going to be assessed. So we come up with the market value, and my market value, not market value, there is a market value and tax assessed value are two different things. In theory, they're supposed to be the same. So my house, if you guys looked it up, is $165,000 of taxable value for my house and land combined together. And so the city goes through and estimates the whole value of all of the property in the whole city. And so from that then, now we have, let me just make up a number, $500 million of property. And so the government then independently is going to set their budget for all of these items. So they're like, okay, people, we need to get at least $50 million to fund the schools, police, highways, budgets, you know, all of the local spending. We need to come up with $50 million. And so the next step in the process is to say, well, in order to collect 50 million from 500 million, I'm going to simplify this so I don't get into too deep of the weeds, since you guys don't really need to know this for this chapter. This is purely for you guys, is to basically do this. And so the 50 million divided by the 500 million means that the tax rate, or what's called a millage rate, needs to be 10%. So that's the process that the local government goes through. They're going to set the tax rate such that they cover the original amount that they were budgeting, which was, in my little example here, 50 million. So if they spend less money, then that would mean your taxes go down, right? So it's all kind of driven through government spending ultimately. All right, questions or comments there? All right. Had I not had my real estate license and was a real estate broker for years, I probably wouldn't know as much as I do. But I had to pass the real estate test every 5 years, and in addition to doing stuff. So, okay. So economists have looked and studied, you know, what we should do, all the stuff that we just went over, police and education and stuff. Who should do it? Should we do it at the county level? Should we do it at the state level? Should we do it at the city level? And so these are the things we need to take into account that will be the answer to that question. So diversity of demand. So within your community, how diverse are your people, right? So lots of cultures, lots of people of all places, all income levels, all whatever. So if the more diverse your demand is, then the easier it is going to be to solve those problems at the local level. So more diversity in demand for public goods means a lower local level. If everybody basically agrees on the same thing because we're all the same income level, we're all whatever, then we might be able to have the decisions pushed up. All right, now to the chat box. Externality, what's that? Hopefully some of you are ready to answer that. What's an externality? Third-party effect. Yeah, I need a little more, but that's probably a short, sweet way to remember it. JC. And Daniel, a positive or negative effect on a third party. Okay, good. So that, and what the third party means is that they weren't part of the transaction. Okay, so externality in general is a positive or negative effect on a third party not directly related to a transaction. So tell me about one of the things that we had on the list before: police, fire, education. Give me an example of an externality. Make it a positive externality. Like, give me an example where somebody got positively, had a positive effect from something that went on in your community related to maybe police, fire, education. Drug bust. Good, Nate. So the drug bust, the transaction, if you will, is the police and them, you know, busting the drug dealers, and that's less drugs that will be out there for other people that might have been impacted by it. Now, if it was within our city, then it might not matter. But if it was in the neighboring city, so if we're in Kansas City and it's Overland Park versus Olathe, those are two neighboring cities. Maybe I should even say, so everybody can kind of relate, Kansas City, Kansas, and Kansas City, Mo, right? So we're across state lines. if that drug bust was the Kansas City, Missouri police busting Kansas City drug dealers, then their taxes all worked out. But that also had a positive effect on the people who live in KCK, right, across the river in the other state. They didn't pay the taxes for the police that went and busted the drug dealer in Missouri, but they got a positive effect from it, right? So that kind of drills down the externality. All right, what about these scale economies? I see some other people made some stuff. Neighborhood Watch, good. How about scale economies or economies of scale? It's always the other big one. What in general, what is economies of scale? Increase in Q, decrease in long run average cost, LRAC, good. So as we increase the size maybe of the police force, then on average, more police can cover more areas, right? So would be an example of a scale economy. All right, so let's see how we did here. Oops, I gotta get my clicker back on. So there, give those a quick read. I mean, we just kind of walked through most of it. That externality is referred to as a spillover too. So outside the school district might be that. Okay, so first let's look at the scale economies. There's been a lot of empirical analysis done by economists. So that's these, research projects done by economists. And what they find is that if we're talking water and sewer provision, then we have moderate scale economies. That, yes, it's true if you have this big waste plant here, and you've got one house serving it, two house serving it, three house serving it, four house serving it, five house serving it. If I add an orange house here, how much harder is it for the waste treatment plant to process it? Not too bad, right? So adding more volume of water waste onto an existing water waste system would lead to economies of scale. And so they do see there being some moderate economies of scale for water. However, when we get to police and fire protection in schools, scale economies seem to be exhausted with about 100,000 people. So once you get up to about 100,000, you're not getting that much additional benefit. In other words, we need to keep adding on more people proportionately as we bump above 100,000. So if we were thinking about this graphically, the economies of scale curve, we usually draw it like this, it's going down, but then if it flattens out. So this is about the point where at this level, the advantages of larger quantity are exhausted. The average cost is still about the same as it was once we get past 100,000 households. Okay, and then the final thing here, intergovernmental contracts. So smaller cities can jointly hire, they can kind of work together on specific projects, and that allows them to maybe get a better deal, right? So it's kind of a volume discount. So if I have somebody who's mowing the football fields, maybe if they get to mow the football fields in 3 different cities, then they can give us a better price, right? So it's just kind of working together as one to try to get better pricing. All right, 10-second pause for questions. All right, so how local should we go is what this set of stuff is looking at. So the metropolitan government versus the municipal government. So this would be at the city level. And here, metro means multi-city. So if we start thinking about the Kansas City metro area, then we have Overland Park and Olathe and whatever. We might be able to more effectively, if there is economies of scale, have a more centralized approach to providing some of the local goods. And so what's the breaking point? It's these positive externalities. So metro government, bigger, will be more efficient if interjurisdictional spillovers, now that's a mouthful, right? We don't usually use this word here, jurisdictional. So among the jurisdictions, so among the cities, if we've got 3 cities together and we're calling the 3 of these a metro area, if the spillover effects are large compared to the diversity of demand, so if the people within these cities have similar demands, then the spillover effect is going to be more important. If they are highly diverse for whatever reasons, then it might not make sense to have the police force be just that. Let's just all keep with our own because I know how to better serve my people, right? So that's the diversity of demand. Okay, so questions or comments there? So the answer is different depending on the magnitude of these elements. So interjurisdictional externalities, that's the size. This is just kind of a summary statement of what we did. I like to have this one in here so that you can think of, this one happens to be near and dear to my heart. Oops. And that is Minnesota. So you guys aren't from there, but maybe you're familiar with the Minnesota Twins, who aren't playing baseball right now. Why are they called the Minnesota Twins? Because this is the Twin Cities. And so the Twin Cities have been a case over time where they have formed governmental bodies to kind of cover both areas. And so Portland is another example. So if you start thinking about the highways, of course, going across 2 cities with my 3 or 4 city area, whatever that metropolitan area looks like, road maintenance, going from one place to the other, that could be one that is somehow shared. And disposal, schools, watersheds, so how the water's going. So there's lots of ways that concentrated amounts of people that are in this similar area can work together to achieve some of these economies of scale. All right, 10-second pause for questions. All right, so we're going to leave you with this. We've got a public good and a local public good. And so a public good in general was what we've seen in principles class and other places. So go to the chat box, whoops, go to the chat box, non-rival. What does non-rival mean in relationship to a public good? Non-rival. Public goods in economics class are non-rival and non-excludable. Non-rival, what is that? Cannot be exchanged or competed with. In a way, I think, Luke, if we could drill down on that a little bit, but you're hitting on some elements of it. Kind of like think about why it can't be exchanged. Might be the best thing. The competition thing is probably true to some degree too, but non-rival. So a cheeseburger is a private good. It is rival and excludable. A cheeseburger from McDonald's is rival and excludable, but public goods are non-rival. All right, good. So yes, if looks like JC kind of hit it there. So multiple people can enjoy it at the same time is non-rival. So this lecture, there's 16 of you or whatever enjoying this lecture, and Jana's enjoyment of the lecture does not take away from Kyle's enjoyment of the lecture, right? So the lecture, the content is non-rival. Non-excludable, what's that one? Non-excludable. A private good is excludable. So what's non-excludable? The cheeseburger that McDonald's sells is excludable, but public goods are non-excludable. Yeah, everyone benefits. Everyone benefits is a little more on the non-rival part there, Jonathan. It's open to anyone. That's kind of the non-rival, but you're getting close, Luke. Think about the payment of it. Can you exclude people who don't pay? Can you exclude people who don't pay? No. That's the excludable part. McDonald's can exclude you if you don't pay, you don't get the cheeseburger. All right, good enough, people. We'll call it a day there.